Hi, my name is Aditya and I am the CEO of Automaski. Today I am going to be talking about how almost everything in the universe is deterministic. Except for a few things in the universe, everything in the universe is deterministic. That's what I'm going to be talking about. So, before we start, a little bit about Automaski. We have been working on complexity theory since 1980s. We solved P is equal to NP in early 90s, got into quantum physics in mid 90s, and within a few years realized this universe is a simulation, and that too a linear order simulation, and that implementing physics won't require of the order of 2 to the power 3 n complexity, but rather order n. We had developed our rudimentary quantum computer a few years later, but only in 2014, when there were massive publications, we figured out which gates to implement and what algorithms to benchmark and test with, hence implicitly achieved quantum supremacy in early 2015. 2 years back, we simulated quantum gravity with a billion qubits. 6 months back, we publicly launched our RSA 2048 cracking service, available for anyone who cares to pay money and use it. Till then, it was available only to Department of Defenses and agencies around the world behind closed doors. And today, we are working on our quantum gravity computer based on causaloid formalism. Again, the quantum gravity computer has been ready for years now. We have been playing with it and trying incremental changes, just that we don't know how to make use of it, because there is nothing published or available out there which shows how something like a quantum gravity computer can be used to solve real world problems. Piece of advisory: please proceed with caution. If this presentation goes against your belief system, then please ignore this presentation, stop the video, and focus on things you are passionate about. If you are respectful and polite, I would love to answer any questions you might have or listen to your thoughts. Feel free to email info@automaski.com. Now, what is Bayesian probability? Bayesian theorem basically calculates the conditional probability of an event based on a prior set of probabilities. So, given a prior set of probabilities, you have a likelihood and marginal, and you calculate the posterior probabilities. Basically, if you know the probabilities of mango being produced and sun shining and rain happening, what is the probability that the mango is produced even if the rain happens, or some conditional probabilities. So this is also deterministic. This can be solved deterministically. Now, fuzzy logic. A fuzzy logic, circuit basically works on something like Boolean algebra, Boolean logic, but it has fuzzification. Instead of 0 and 1, you have variation in a distribution of probabilities between 0 and 1, and that is called fuzzification. And then you have logic and math operators and if then else rules, and then you defuzzify to get the results. This can also be solved deterministically. Petri nets are basically distributed, a way to model distributed systems. It is basically a kind of representation to model workflows, and it has states and transitions, or places and transitions. Petri nets can also be solved deterministically. Monte Carlo simulations are basically a model used to predict the probability of a variety of outcomes when the potential for random variables is present. Let's say you have, you know, uh, let's say you want to measure the probability of thunderstorms. Now, thunderstorms depend on a randomized set of parameters like temperature, humidity, sunshine, wind, turbulence, etc. So, given all these random parameters and their probability distributions, what is the probability or the probability distribution of rain and thunderstorms? Such kind of things can be done with Monte Carlo simulations, and this also can be done deterministically. Markov chains is basically a stochastic model describing a sequence of possible events in which the probability of each event depends only the state attained in the previous event. So till now, if you have achieved a certain state, you are going to then have a lot of options for the next step, and the probability of all the options or the choices of next steps will depend only on your current state. This can also be done deterministically. Reinforcement learning is an area of machine learning. There are companies working exclusively on reinforcement learning as a means to develop AI. And an agent is basically supposed to take actions in an environment in order to maximize the notion of a cumulative reward. So basically, you have an agent and you have an environment, and it can do a lot of things, out of which some will lead to rewards and some will lead to penalties. And it is the job of the agent to maximize its rewards. This is done through reinforcement learning, and this can also be done deterministically. Game theory is basically a study of decision making where your actions and choices depend on the collective actions, not collective actions, depends on the actions of everyone else. This can also be done deterministically. And basically, you have to maximize payoffs. So, this can also be done deterministically. Decision theory is a branch of applied probability theory and analytical philosophy concerned with the theory of making decisions based on assigning probability to various factors and assigning numerical consequences to the outcome. Basically, if you have a lot of parameters and they have probabilities, and you need to take a decision so that you can achieve an outcome with a certain probability, this is called decision theory, and this can also be done deterministically. Probabilistic programming is a new way of a path-breaking way of programming, AI and neural networks, etc. What is done is that you build a model and you observe the results, and then you reverse infer the parameters in the model and the probability distributions of the parameters in the model. This is called probabilistic programming, and this can also be done deterministically. Just like you have a classical computer, you have deterministic Turing machines. You also have something called non-deterministic Turing machines, which are exponentially more powerful than a deterministic Turing machine or a classical computer. Basically, in a non-deterministic Turing machine, the execution path at every step has multiple choices, and it can tread down any one of these choices, the paths, subpaths. Non-deterministic Turing machines can also be solved deterministically. Classical quantum walks. Basically, random walks are like a Markov chain, and basically it is a key in many quantum algorithms. Basically, you have a drunk walker which will randomly go left or right or on a lattice at every point in the lattice, and then you arrive at a distribution or a hitting time if you want to hit some state in the lattice. It is a universal way of programming quantum computers, and this can also be done completely deterministically. Quantum computing, you all know what quantum computing is. Basically, you have a circuit based quantum computer here, shown here, a quantum circuit, and it executes and it gives you a lot of probabilities of a lot of results. It is very confusing to think of it being possible to be done deterministically, but entire quantum computing can be done deterministically. All of these are deterministic and can be done in polynomial time. They don't require exponential time. These breakthroughs at Automaski are truly some of our best millennium breakthroughs. Determinism versus non-determinism was a debate we settled in the 90s. But as we looked more and more at sciences and maths, while trying to solve a lot of problems in polynomial time or approximating them, a majority of things turned out to be deterministic. This opens up phenomenal possibilities for mankind. Imagine entire quantum computing being deterministic. Markov chains are deterministic. Reinforcement learning can now be deployed in production use cases because they don't require exponential number of samples and can be done deterministically. Being able to do all of these problems deterministically in polynomial time is perhaps the biggest millennium breakthrough at Automaski. You might not want to believe it, but either way, this is the way it is, and it is not going to change. So, congratulations and enjoy. You take the blue pill, the story ends. You wake up in your bed and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. Remember, all I'm offering is the truth, nothing more. Thank you. If you have any questions, you can email info@automaski.com.